Manuel has come to us from very far away, thankfully, and he's been working on GHC and the Haskell community for a long time and is now active with the GHC DevOps initiative, and today he will talk to us about continuous integration and testing for GHC. Give it up for Manuel.
Thank you. Hello. Thanks for coming. Continuous integration, this testing is usually the kind of thing people decide to maybe run away from because it sounds maybe not that exciting compared to generative, higher order, functorial, categorical, whatever. But we have to do it. So the question may arise, so why did they ask me to come and talk to you about this stuff? And so I'm going to use to tell you about my involvement with GHC. I'll use it as an excuse to tell you about me. So I used to be actually a professor for UNSW, that's a university in Sydney. And during that time, we had quite a few projects with Simon Peyton-Jones at Microsoft, and in particular, I implemented the associated types and type families in GHC. So I did quite a bit of GHC hacking in that process, as you can imagine. Our research group also developed data parallel Haskell, Rapper, Accelerate, Vector. Duncan visited us when he did the build fusion stuff, stream fusion stuff, so lots of things. And I'm the developer of Haskell for Mac, which is an IDE for Haskell IDE for the Mac, and that links GHC as a library. So I'm doing a lot of stuff which GHCI does, which is a totally different part of GHC than the type checker where type families went into. So these days, I'm working for TWEAG.io, who's one of the sponsors of this great conference, and through them mostly on a blockchain language for the Cardano blockchain as part, which is developed by IOHK. But really, one of my jobs at TWEAG is community involvement, and because TWEAG does a lot of work with Haskell, we are extremely dependent on GHC. So we really care about GHC. We care about GHC being as good as it could possibly be and being very reliable. And that's what brought us to be involved in the formation of a group which we just heard about, namely the GHC DevOps group. So let me tell you a little bit about this effort. So the purpose of the GHC DevOps group is basically threefold. So first of all, it used to be, GHC started out as kind of a research project of Simon Peyton-Jones and some of his students, right? And it grew now into a software system which actually quite a few companies depend on. So that means the development process has to change, and also Simon didn't feel comfortable to be responsible for all of that anymore. So the idea was to kind of get the community involved. So that's reason number one. The other reason is that as it's become a bigger project, like the resources of one research group or something like that are just not sufficient anymore. So there are a lot of companies depend on GHC, but that also means there are a lot of people who should be interested to maybe provide some help with developing GHC. So to organize that better, bring everybody together, pool the resources, that's number two. And then related to why we are here today, we want to get many people involved, and we want to talk about it, and we want to tell everybody about what's happening and how they might be interested in, maybe help with it. So that's the third point. So if you want to know more about the DevOps group, you can go to the GHC Wiki, and there's a page about it. And we are looking for more people being involved. So if you're interested in this stuff at all, after this talk you are not scared of, but you think this is really important, which I think it is, then you would be very welcome. We really like more people to get into this. That's really why I'm here. All right, so how did this all come about? So last ICFP in Oxford, it's basically GHC HQ, so the two Simons, and a few stakeholders, meaning people from companies such as TWEAG, Welt, and Barclays, Bank, Standard Chartered, so people who use GHC for a living, basically, bunched together, and we decided to start this whole effort. And what our goal, we wanted to have a very clear, focused goal, not just some random committee, but what we're concerned about is make GHC reliable, make sure it's released on a timely basis, and it's of a high quality. The software inside the compiler is of high quality. And we want to get everybody else to be interested in it as well. So that's how this whole effort came about. So we should talk a little bit more about the aim here. So it's really very specific because in the whole ecosystem, there are already some other groups. So with the DevOps group, we care about the GHC development release process, but there's also the GHC steering committee. Who knows about the GHC steering committee? You people. So the purpose of the GHC steering committee is to decide what user-facing changes, especially what changes to the language are being made. Because that's obviously very important, as the whole Haskell standardization process isn't really very active anymore. It's really GHC's development which is driving the change of the language. So the feeling here also was that's not something which should just be decided by the Simons, but there should be a community involvement. And that's what the steering committee is about. So these are two separate groups, and there's some overlapping membership, but they really aim at two completely different problems. Then we have the core libraries committee. That's responsible for the core libraries and the evaluation of the core libraries. We really don't care about the libraries. We care about, so GHC DevOps cares about the compiler, not the libraries. And then we have Hackage, and that's yet another separate group of people who look after Hackage. So really what I'm trying to say here, GHC DevOps is really about that one specific thing. GHC releases, keep them high quality and keep them coming on a regular basis. So what does that mean? And well, I'm talking about quality and reliability, but is there a problem? Do you think there's a problem? Nobody wants to commit to that. The camera may pick it up. Well, let's look at that. So historically, this is something I had in a talk at the Haskell Implementers workshop at exactly the ICFP where we formed the group. As kind of part of the motivation, well, there are things like this. So the first ticket was like a performance regression in attoparsecs. These are all things which happened, which people noticed after major compiler release, right? So compiler was released, everybody thought it's okay, and then suddenly big problems arose. Then the second ticket is segfault with stable names. Maybe you don't care about stable names, but as I mentioned, one of the projects done in my research group at UNSW is the Accelerate Array library. It's an embedded domain-specific language for high-performance array computing with Haskell on multi-core CPUs and GPUs. And stable names, it's an EDSL, are super important there. And basically what we found after this version of GHC, SM82, was released is, well, you couldn't use Accelerate. Basically, it was completely unusable. That's a bad thing. And it wasn't the only library which had that problem. Then static pointers. That's something which happened, and it destroyed a few of those inline something or other libraries. So inline Java is the one TWEAG created, one of the inline libraries TWEAG created, and it was broken by this. So that was a big disappointment. And then this particular bug, vector library. I mean, who here uses vector? I mean, if you don't use it directly, believe me, you're using it indirectly. So vector broke. That's bad. You would have think somebody should have picked that up. So maybe there's a problem here. So this thing doesn't want to work. So you may wonder, so I said this historical, this is the things I presented at ISFP last year. So did it get any better in the meantime? That's a good question, glad you asked. Well, I'm not so sure. Some things did get better, so this clicker definitely doesn't get better. Maybe it's running out of battery. So this is a recent release, 8.4, and it's really, I think this is a really bad bug in the type checker. So deferred types means you can run your program even if there are type errors, and that's quite useful in development. And it doesn't work anymore. Oops, kind of a core feature. That shouldn't have happened. This one, well, if you're a Linux user only, then you don't care about it. But if you're on Mac OS and Haddock in certain combinations doesn't work anymore, oh, that doesn't sound good either. So that's one problem with this whole CI thing. So who is only using Linux? Only Linux. Okay, who is also using Mac OS? And who is using Windows? All right, so, I mean, there are a lot of Linux users. This is not surprising. You'll see development community is very Linux focused. The user community is different matter. But obviously, there are a lot of Mac OS and Windows users as well. So you need to test this stuff as well, right? I'll get back to this point. So it's a bit hard to tell whether things got better. There's definitely still big problems. So why? We started a process to improve the whole DevOps situation, the whole testing and so on situation, but obviously this process hasn't finished yet. So if you want to help, there's still scope to help, obviously. So what are remaining problems? I mean, it's a hackathon, right? You want to know where the problems are so you can fix them. Isn't that why you're here? So obviously, we still have things which break in a bad way. Secondly, this whole platform-specific breakages thing obviously isn't under control. So we have things breaking on macOS, we have things breaking on Windows, which haven't been picked up because some CI processes only run on Linux. And the whole CI process also has problems, which I'll get to in a moment. And then also, there seems to be a lack of test coverage. I mean, if these breakages, the 2 tickets I showed you of the recent compiler version, if they can slip through, then what's the problem? Was there no test to test it, or wasn't the test run on the right versions of GHC? So that's 2 different kettle of fish, right? We could not have the tests, or we could have forgotten to run them. So which one is it? So that's an issue we'll look at later as well. But it's not just about quality. When I said the mission, when I stated the mission of the DevOps group, I said we want high quality releases, but we want them on a timely basis. So how about the timeliness? Well, this is from a blog post Ben Gamari wrote half a year ago, where he just made a list. And you can see it's quite varied. So there are sometimes releases where in quick succession, and then there was a 19-month gap between 2 versions of GHC. And that wasn't before because people thought, let's have the next version of GHC really far away in the future because we are not keen on making another release. But it was because towards the end of the release process, bugs crept up, which keep delaying the release. So that's really very bad. So what we decided is, as part of the DevOps effort, is to say, okay, instead of waiting for which features are ready, and let's try to wait for that feature, and then that breaks something, and now we have to fix it, we are doing something different. What we are doing, which is really the way you should organize your release process, we specify a release cycle. We want to have releases every 6 months. And then things which are ready get included, and stuff which doesn't work, we just chuck out. We don't delay the release for these features which would be great but aren't ready. We just ship what works. So since then, we had one release, 8.4, which still has quality problems, as we just saw, but it was produced on time in the schedule we had in mind. And the next release, 8.6, is planned for September, which means the release branch will be cut sometime this month. And at least we have a plan to get it out by September, and I'm quite hopeful it's actually going to work. So some things improved. So the whole timing thing we got under control to a certain extent. Yeah, I mean, we'll have to prove that it's staying under control, right? We haven't that many data points yet because it's a new effort, but we are going the right direction. So things are happening, that's good. So what did we do? So one thing we did do to get the releases under control, really have a clear plan of how a release is being made. And branch early. So you may or may not know that the way GHC releases work, there is the master on which all the changes happen, and then we branch off a release branch, and then maybe some of the changes on master are still merged into the release branch, but it is that release branch which will finally be released as the new version. So the way we are doing this is a schedule like this. So 2.5 months before we want to make the release branch is created. And at the same time, Ben makes an alpha 1 release. So that's a compiler which is really for people who are interested to kind of do early testing and for us to get some feedback whether the thing kind of at least works somewhat, and somebody other than GHC headquarter can actually build it and it doesn't fall over. So that's a very early version. And then we have a second version a month later, and then more versions every 2 weeks until we hit the release date. So in that way, we have 4 candidates. Now, if there's a problem, so this is what happened for 8.4. Now, if there's a big problem in release candidate 1, then obviously there would be more release candidates. So in that case, it was actually quite good, which is new, because if you've been involved with GHC development or looked at the mailing list prior to this change, which we instated half a year ago, then you may know there are usually lots of release candidates, and at the time where we had this 19-month kind of gap between releases, there was a lot of churn in between. So that's at least going the right direction. That's the process which we're using at the moment. All right, so some things work, some things don't work so well yet. So what would we like? What's the ideal situation? Let's have a look at that. So the ideal process, first of all, has to continuously do testing. What that means is whenever something is merged into master, it needs to be automatically tested, not just on one operating system, but on what's in GHC speak is called the tier 1 platforms, and that's Linux, Mac OS, and Windows. And the GHC regression test suite, as you may know if you've used it ever, has 2 modes. It has a fast and a slow mode, where the slow mode just includes more tests which take a longer time. And so for this integration testing, we really want to run the slow one. Yeah. Right. So the question is about what about architectures? I'm only talking about platforms, and you're totally correct. So that's different for different OSs. What's being considered a tier 1 platform is a combination of operating system and architecture. I was simplifying here. So in the case of Linux, it's 32 and 64-bit. In the case of macOS, it's only 64-bit because even Apple, actually in the new version, macOS Mojave, which is just in beta, since last week. They previously deprecated 32-bit applications, but they don't even Apple doesn't fully support them anymore, so GHC doesn't have to support it either. And on Windows, ideally, I think we also try to do 32 and 64-bit, but I think 32 is, I'm not sure in what state it is. PowerPC and so on, I mean, there are of course more architectures, but they're not tier 1 architectures. What does it mean to be a tier 1 architecture? To be a tier 1 architecture means that not that we like the architecture or we like the operating system, but they're actually people who promised that if something breaks for that architecture or that operating system, they are going to, on short notice, fix it. So if you think there should be more operating systems or architectures in there, well, find somebody who's going to put in the work to make it happen. It's not that we prefer something or don't like it, it's that there needs to be people who maintain it. Does that answer the question? All right, so for everything that's being merged in, we need to build and run the tests. But that's actually not enough. In order to achieve a fast release cycle, if you've looked into continuous integration practices, then what you really want to do, you don't just want to build and test your stuff, you actually want to run a full release. You want to build all release artifacts, all the documentation, everything, as if you were making a release. Why is that a good idea? Because the day you're making a release, you just bless one of your nightly builds and say, that's my release, because that's the one which works. And in practice, this has actually been another reason for the delays in GHC releases. Namely, it used to be a very manual process to do a GHC release, meaning a lot of work for specifically Ben Gamari. And then the trade-off is, of course, I mean, how many releases do you want to make? Because this distracts somebody who is able to do fix bugs and distracts them building documentation for how many different platforms which are involved in a release. So by automating all this, that's important precondition for having a faster release schedule. So not everything is automated at the moment, but that's also part of the effort here. Yeah? That's the excellent question. So the question was, shouldn't we actually run the test suite before we merge a change? That's a brilliant question, which is why it's on the next slide. Thanks for the transition. So actually, what we would want is that once somebody submits a change, then we test that change before we even merge it in. And with that change, then the question is, of course, do we run all tests on all submitted patches? And that's the question of resources. As if you look historical at the contributions of GHC, we are in the very fortunate situation that there are more and more people contributing to GHC, which is great because we really need it. We need that effort to keep the project going. But it also means there are more things to be tested, which means you need more servers and so on. Also, there's another tricky point. Namely, let's say one person submits a patch, another person submits a patch at about the same time. So then these are tested independently. Each of those passes CI. And then you merge them. Doesn't mean the two together will still work, right? So I mean, this is not GHC specific. That's, of course, a common problem. And there are some tools trying to work around that. But it's not quite clear what you want to do here. Anyway, we definitely want to do something like that. We definitely want to do some testing, at least, well, actually as much testing as we can afford to have servers for, of things which are just submitted for integration. And then look at that as part of code review. So now the resource question, of course, brings us to where do we run all these 5 million test builds? And with the different architectures, everything together, GHC is at a point where it needs a quite significant server load to build everything, right, all the time. So traditionally, GHC very much had, because it started as a research project, so somebody ran the server, basically, of the development team. It started out as a completely self-hosted thing, but that's, I would argue, really bad use of our time. Because doing these things, doing proper continuous integration, all these things, is actually not that easy. And doing it for different operating systems, you have to know the specifics of the various operating systems. So Ben used to spend a lot of time on this. And I think it's bad use of his time, because he's a very smart, capable developer who is able to fix really weird bugs in GHC. And they're not, I mean, I would say there are not that many people who have that ability and that variety in what they can do in GHC as Ben. And to make him install different versions of different operating systems on some random servers, that doesn't seem to be particularly good use of his time. And use of his time means, well, the good guy has to eat as well, so he's not working for free, and somebody's paying that, at the moment, Facebook. And so is that a good use of our resources? I don't think so. So we've made an effort to move towards hosted solutions. And another reason why we could do this is because I started out by saying, well, the DevOps group was formed by GHC headquarters, coming together with stakeholders, meaning people who really depend on GHC, who make money by depending on GHC, and who are more than happy to chip in order to keep GHC running. So what we've done over the last half year, we have moved the testing of Linux and macOS builds to Circle CI, and of Windows, my clicker is really not working well today, of Windows builds to AppWare. Now, with AppWare, the resources they provide out of the box are not sufficient to build GHC. GHC takes quite a while to build and run all the tests. So Google kindly is providing resources on their cloud infrastructure for free to do the build through AppWare, but using the Google instances. So Google also uses GHC, so they're also interested in keeping it going, which is good. And so this process isn't finished yet, as I'll tell you in a moment, but we really want to go as far as possible towards hosted solutions, because it's just as time goes on, there's more and more work to automate everything, and people like at Circle CI and AppWare, this is their day job. They're experts at doing that, and there's no way we can replicate what they are doing in a sensible manner without distracting us from actually writing Haskell code and making GHC better. All right, so that's the setup. Now, earlier I said, well, it's all good and fine to run the tests you have and use this infrastructure, but these failures which we are seeing, are they because we don't run the tests when we have to run them all the time? Maybe we run tests on a pull request, but we don't run it on all the merge builds or something like that? Or is it because we don't have the right tests? And that brings me to an effort which we have started at TWEAG, which I talked about at the Haskell Implementers Workshop in Oxford last ISFP. And that's, if we look at some of these package breakages which we've seen before, so out of the 6 tickets you saw in the talk so far, 5 of them are actually things which manifest when you build particular packages. So now we could, of course, say, well, the GHC regression test suite should cover that. Ideally, it should cover everything. But that's very hard to achieve, right? And we have all this code out there. On Stackage, there are lots of packages which we know people use a lot, because otherwise they wouldn't be on Stackage. Stackage requires somebody to step up to say, okay, I'm a maintainer of this package. On Hackage, there are many packages which nobody cares about. They've been abandoned for a long time. But everything on Stackage at least still has somebody who claims they maintain it. And so it seems kind of sensible that we could use that as a test suite. Right? I mean, this is all code which already exists. A lot of these packages have test suite components in their package descriptions. Some of them have benchmark components. I mean, it's all great stuff. People put effort into writing all those tests for those packages. Why not reuse it? And things like accelerate braking with stable pointers. I mean, if accelerate would have been part of the regression test, it would have been obvious. So we've started this, and the way it works, I don't know how much you know about Stackage. So Stackage is constructed automatically. It's mostly an automatic process. So what goes in there, what's interesting for us is there is a file which is called build constraints, and that's the only manual component. So it's the, what are they called? Stackage curators, I believe. So that's a handful of people who look at different versions of these packages, what works in combination with what, or at the breakage is reported by the tool, and then send an email to maintainer saying, well, this is not working anymore, fix it, we comment it out for now. And so this file is manually curated, but everything else is fully automatic. So, and there's a tool called Stackage Curator, and that tool reads A, the build constraints, B, scrapes all of Hackage, and then looks at the current snapshot of Hackage and the current build constraints and figures out what is buildable and builds that. And that goes into a Stackage snapshot. So that tool does that every night, producing a Stackage nightly. And it does it for these LTS Haskell releases, which are basically blessed releases, which you use for production. But the nightly builds, they're done every night. I wouldn't recommend using them for production, but they're part of the process of finding the next good set of packages. So these Stackage nightly builds, they are up to date with the latest version of everything on Hackage. So they seem like a good thing to use for regression testing. So how can we do that? Because usually they're built with the latest release version of GHC, but we want to use it with a development version. So the way the build of a Stackage nightly works is that it uses Docker containers. So it starts with the Docker Ubuntu container, and then slurps in all the non-Haskell dependencies, the compiler to build the GHC being used for the construct, for the actual build, and so on, to produce a new Docker container called Stackage nightly. But that's the one which is used by the Stackage folks for the version for GHC release. So now what we are doing on top of that, we are building another Docker container out of the Stackage nightly, and that one we integrate the latest version of GHC built on Circle CI by our continuous integration process. So what we talked about before, the stuff which is built with every single version of every new commit to master, that's the version we are using in the Stackage head build. So then that takes the build constraints, and the Stackage Curator tool constructs a build plan, basically figures out which packages to build in which order, in which configuration, and then it builds all the packages. So you get one snapshot. Now for the release compiler, Stackage guarantees this is going to work out. For the development compiler, usually it won't work out because some things will have broken. I mean, it's not a released compiler, and maybe packages haven't been adapted to the latest changes in that version of the compiler, and so on. So you can't assume this is going to work for every single package. But what we are doing, we are saying, well, we can compare these builds. A single build may have broken things, but if we take a version of GHC and a change, so like a pull request, then we can build this using one build plan, run static curator with that one build plan on the reference version of GHC, basically what happened last night, if you like. And then we use the same build plan, we don't make a new one, we use the same build plan and run it again with a new version of GHC, with a slightly patched version of GHC. And then we compare the outcomes. Because everything that's different between these two results must be due to the changes in GHC. So then I talked about this process at the Haskell Implementers Workshop, started to implement the tool, and then Mark Karpov, who is also at TWEAG, he completed it. And so now there's this version where you can go to this URL. We are going to register a domain and come up with something which is a bit nicer than what's on the slide. But it does already give you this report. So this, you can click on those, and then you get details on what changed, where something changed. And you can dig into what broke, in what way, and possibly why. So if you're interested in this project, this is still fairly experimental. It's on GitHub, of course, so in the TWEAG org under Stackage Head. And there are also 2 blog posts. On TWEAG.io, we have a blog role, and there are 2 blog posts which describe the original idea, and then Mark wrote a post when he had the version implemented this, producing these HTML pages with the diffs, and you can have a look at how that works in detail. So this is still something we're working on, but we'd be very interested in people helping out. Yeah? Okay. Yeah. Yeah, so the question is, what do we do when something breaks? Well, at the moment, we have a process to inform library authors, but the question is, there can be 2 reasons for something breaking. It could be somebody introduced a bug in GHC, and then, well, we should tell the GHC maintainers. And at the moment, this is not integrated in the GHC development process. It's something where, as I said, we just still developing. Or maybe GHC changed. And then the package author should know about it, not necessarily to fix it right away. I mean, it would be nice if they fix it right away. But at least they should know when the next version of GHC is released, they really have to fix it or their package won't work with the new version. So they get a head of a release warning. And yeah, at the moment, we can notify the package maintainers, but yeah, I think, so this is one of the open issues here. Exactly what should we do, and do we have a way to decide between is it a GHC fault or a package fault, and exactly how do you want to structure notifying the various people. That's definitely something where I would very much welcome any ideas or suggestions, and where also automation would be quite helpful. Yeah. So it's basically to say, I don't have a good answer for your question, but we should really think about it. And I mean, these are the alternatives. Yeah. Yes? Of course. How can we know whether a package fails without building it? Yeah, I know. There are not that many packages. So at the moment we are building this on Circle CI as well, and we use a fairly big contingent of servers, and then it actually doesn't take that long. Yeah. So it's this is highly parallelizable. It's one of these things where you can throw a lot of resources at, and then. But it's worthwhile, yeah. Dependencies. That's one of the reasons why we built this on Stackage, because as I said before, Stackage builds this Stackage nightly Docker container, and the Stackage curators, that's actually their second job. Their one job is to do the build constraints file. But there's another file which is basically the Docker build file for the container, and it's based on Ubuntu, so it has apt-gets for all the C dependencies, and the stackage curators, they keep that up to date as well. So this is a way, using stackage here, so I motivated it by saying, well, all the packages which are on stackage, somebody still has a stake in them, so it's a good set. But it also means the stackage folks do a lot of work for us, namely what you just brought up. Nikki? So that's a good question. The question is, can we test performance this way? We could. At the moment, we don't do this, but a fair number of the packages include benchmark sections. And stackage allows you, so stackage curator allows you to run performance tests, and it would be very worthwhile to do that as well. At the moment, we don't do this because we are still trying to get the regression testing integrated in the GHC process. But once that's done, I totally agree, it would be really good to do that for, pardon? Whether you can do it at the moment? Yeah, so we run it on Circle CI. So your question is about virtualization, whether it makes sense to run performance tests on that? That can be an issue. So, I mean, we would have to see how reliable the results sind on a virtualized infrastructure. Yeah, as I said, we haven't tried it yet. But stackage in general provides that ability. And maybe we would want to run regression tests, performance regression tests, which would only be a subset of the packages anyway, on an architecture where you have the box for yourself. There are no other processes running. But I think it's possible to do something there. It would be worthwhile. It's nothing we've done, but there's certainly the option. Mm-hmm.
Exactly what cycles.
Yeah. So the point is having a performance solution, cycle-based performance solution, which is invariant under virtualization, basically, right? Yeah. So I think I mean, this all shows there are lots of good things which can be done here, which haven't been done, and yeah, help appreciate it. Oh, okay. All right. Yep. Any more questions? Questions are good. All right. So let's look at some of the problems and where they come from. So let's stay with stackage head for the moment, and then we're going to the general CI infrastructure. So one problem which we found, not too surprisingly, with stackage is sometimes there are changes to GHC, to like base or something like that, which break something like vector. And there are some packages or text. When that breaks, very little builds, because everything somehow depends on it. So that's annoying. And coming back to your point about what do we do with the results? Can we notify package maintainers? I think for these core packages, which are in the dependency graph, basically in the middle of it, it would be really worthwhile to adapt those to new versions of GHC right away, even if the GHC release is still 2 months away. I mean, and this is not just for CI, because a problem which we have also in the past is a new GHC comes out, right? And then text doesn't work. And then all the people who want to update their Hackage packages for the new GHC find when they want to update their stuff that their dependencies don't even work. So they go, well, I'll try again in 2 months. And then you get the situation where you have a release which is basically unusable for three months because basically nothing you want to do with it works. And so by taking those core dependencies out of the update process after release and putting it into the later phases of the development release cycle, which I mentioned earlier, would, I think, really improve this situation so that when GHC comes out, most of the packages already work. But, yeah. Yeah, so how do we determine who's at fault, GHC or package, which is related to Nikki's earlier question. So I don't think, I mean, if you've got any ideas, let me know, but I wouldn't know how to do it fully automatically. I think what we would want to have is actually Stackage Head being run as part, or at least part of it, as part of the testing of individual contributions to GHC. Not only after they're merged, but while they're pull requests. Then, it's the responsibility of the person who's submitting this patch to GHC to look at the failure and say, oh, I know, yeah, I changed the language, I changed the meaning of what whatever monomorphism restriction means, and yeah, I expected half of package to fail, yes, submit, merge. Or to say, oops, and go away and fix their patch. I think having that feedback at that point would be the easiest way to determine it. But that requires it to be integrated in the whole process. Yeah, but this is definitely something where some good ideas could still help, yeah. Mm-hmm. Right. So is this released versions of Perl or development? Right. Yeah. So there's something on Haskell which is called the build matrix, which does something like that for released versions. I think the tricky bit is really in the development version to identify whether, and this is really out of the scope, I think, of automation. Mm. Yeah, so in GHC this is unfortunately not true. You may wish it were true, but it's not true because, so for example, remember the changes to the monad functor class hierarchy, things like that? That always breaks things. And it breaks them on purpose. And in GHC releases traditionally, most releases have something like that. Some are worse than others. But that's why just saying the last release build it isn't a 100% guarantee. It should still build. But of course, yeah, I would say usually it's the compiler's fault if it breaks. Yeah. Okay. Then another problem, which is also difficult to solve, to be honest, is fragile tests. So we use the tests which people include in their packages, and some tests are not very reliable, meaning they sometimes fail. And that's really something where the package author should improve their tests, but of course we can't guarantee for all package authors that they are putting in the time to improve their tests. So fragile tests is something we found looking at the results of the stackage tool. Of course, here one option would be to blacklist some packages. If we know one particular package has particularly unreliable tests, as long as it's not vector, and then we would really want to fix it, we can just blacklist it and say, well, we don't take that too seriously. We could, over time, develop, like, what's the probability of package XYZ to fail spuriously, and then say, well, are we at a confidence level where we want to report a problem or not yet? Yeah, that would be something to consider. The more serious you want to take it. Yeah, that's definitely true. So then, I said that before. So at the moment, stackage head is completely independent of the development process, which is obviously not ideal, but because it's new and it's still in development. But that's something where, again, this is where people interested in working on things. That will be good. And one big problem, which is hard to solve, it's Linux only, which means the breakage I had earlier on macOS, that was a Hackage package. It could have been picked up by this process, but no, because it only runs on Linux. And it's not so easy to solve because stackage curator depends on Docker, and Docker obviously can only run things on Linux. So some things are hard to solve. So how about the overall CI infrastructure? Because as we saw, we still get broken releases. So, and that's also things which help appreciate it. So first of all, at the moment, not all tests on CI actually work. That's not because, this is not really a regression, but in the process of moving tests over to Circle CI, we actually extended the set of tests which are used during CI. So there are some tests which historically in GHC have been broken for a long time, and because they weren't run so often, people kind of ignored it, which are still failing. And so there's some excellent contribution would be to go and fix some of these things. Because obviously it's, regression testing is not very useful if you know some things are failing anyway. Secondly, and this really gets us into software development process, at the moment, people are actually, if you go onto the GHC GitHub page, you're discouraged from submitting a pull request. They tell you, go to this other site, don't do it here. And that's a problem. So at the moment, you're supposed to use Fabricator for bigger contributions, but Fabricator doesn't integrate with Circle CI. And, well, we could do it ourselves, and Ben wanted to do that for about 5 months. And this is not to say Ben should have done it, because Ben has a lot of work to do, and he's done a lot of great things in that time. I think it's another indication for why we shouldn't self-host our CI stuff, and we shouldn't write our CI process software ourselves, but let somebody else do it. And unfortunately, Fabricator isn't very good for that, because it forces you into doing lots of things yourself. So that's a big problem. And it prevents us at the moment to have the tests on the pull request. So we only, de facto, GHC only properly does CI on merged changes at the moment, which as we discussed, isn't a good situation. So I'll say a little bit more about that in a moment. Also, we said we don't only want to run the tests, we want to also create build artifacts. That's something which happens, but it's not completely automated and done in the way we would want to. And that's mostly also because Ben has too many other things to do. So it's also something where help would be very much appreciated. And it would just make the release process a lot smoother if this was all done automatically, which would be good. Freeing Ben from doing manual tasks which could be automated. And also, there have been all these changes over the last 6 months, and little of that is reflected in the track, GHC track. None of that is reflected in the documentation on GitHub. So improving documentation is also something which would be great if some people would be willing to help with that. Yeah. We at least have a summary ticket to fix these failures, which I'll give you the number of later on. Yeah, so there's a ticket kind of make the CI green, which is exactly about this. Yeah. So this is a little bit, so there is also part of a documentation problem. So Ben knows exactly what the things are and kind of has an idea, at least for some, why they might be breaking, but it's not properly written down. So again, documentation lags behind the current situation. Now, again, this is not Ben's fault. It's just too many things on his plate. So let's look at this again, because this is something I care about. So let me ask you, how many of you are using GitHub? I thought so. How many of you have used Fabricator? And this is like people interested in GHC development, right? So this is not an ideal situation, and it's kind of gotten worse because so what GHC has been using is this website facility, which is a hosted solution for Fabricator and a UI to do code reviews on. And these people, as is their total right, of course, have changed their business model slightly. So where previously was possible to have free accounts, use it for free, and they would respond to such sessions, they are not doing this anymore unless you have a paid plan. And so which changes the GitHub versus Fabricator/facility trade-off. And so you might ask, why are we still using that? Why haven't we kind of said, well, let's just use GitHub like everybody else, almost everybody else? So that's a social question. So on one hand, we have people who like Fabricator, for example, Simon Marlowe, who is, of course, very important in GHC development, because it's this tool he uses at Facebook as well, and he knows how to use it, and he likes it, and he likes GitHub less, and he doesn't want to change. Fair enough. So we are in this situation where if you want to contribute something, you have to install this ARC tool, you have to figure out how this all works. We can't have proper CI integration for what's called, so a pull request in Fabricator speak is a differential. We don't have CI properly on differentials because the integration with Fabricator doesn't work properly, or it's back-end thing called Harbor Master. So one thing people have, including myself, has argued for, let's just use GitHub. And some people argue code reviews on GitHub aren't so good. Then that's, again, a process question. So GHC historically has very big pull requests. So people kind of accumulate a lot of changes and then dump them onto code reviewers at a time, which again, in itself, is already something some people argue is not a very good practice, but that's the situation it is. And GitHub doesn't have great support for this style of working, which is true. But there are other solutions. So there's, for example, a service called Reviewable, which integrates with GitHub. It just uses standard GitHub pull requests, and it just provides a more sophisticated code review facility. So it's basically more Fabricator-like code reviews, but you don't have to use different software. You still can use normal pull request functionality on GitHub as you're used to. And so that's an alternative, for example. Yeah. So the reviewable automatically includes a link in the pull request, which brings you to the data on reviewable, and I think it's stored. At least part of it is stored on their servers. So they store more information than what GitHub stores, and that information they can't easily integrate into the pull request, I guess. So one thing is, for example, if you have large contributions, large pull requests, and the reviewer annotates individual lines and kind of comments on them, then GitHub has this strategy when you push something which affects the line, it basically folds away those comments. And then it can be hard to keep track of what has been said in the past about particular lines and so on. That's something which Fabricator is more sophisticated in handling, and those guys as well. And that information, this line information and associated comments, that's really information they can't keep on GitHub, logically, because GitHub, and that's the limitation, doesn't maintain this information. Mm-hmm. So I didn't quite get the question of whether there's somebody else who does the Fabricator integration. I don't think so. So the question is whether there's a hosted solution which integrates with Fabricator. I don't think so. So the thing is, Fabricator itself has its own infrastructure, which is called Harbor Master, for doing regression tests or doing builds on differentials. But that requires you, again, to maintain your own infrastructure. And then you can integrate that with other hosted solutions. And for example, older versions of CircleCI had an integration with Harbor Master, but then Harbor Master changed and CircleCI changed and nobody ever updated it. So it's a usual problem. If you don't use a standard thing, then it may break and it's out of your control. Whereas these services like CircleCI, they of course do all the work. When GitHub changes, they change because they would be out of business if they don't change. So that's kind of, in my opinion, the better situation to be in, where the third party you rely on has the same interest as you to keep working with the other parties you depend on. Yeah. Sorry, didn't see you. Yeah, so the question is, can't CircleCI build push the information back to Fabricator? The problem is more the other way around. You submit a differential to Fabricator, and now that has to trigger CI on CircleCI. And technically, it's possible, right? CircleCI has an API, and you could write all the Harbor Master scripts to do that, but somebody would have to do it. And Ben has had on his to-do list for the last few months, I should really do that. It hasn't happened. And as I said, it's not Ben's fault. He has lots of things to do, and I think he shouldn't have to do these kind of things because his skill is best served in hacking Haskell GHC. Yeah. So what's the tool called? BuildBot. discussion document or something. So the comment was about what LLVM does, and there's a tool called Buildbot, which has some fabricator circle CI integration, which would be worth looking at. I hadn't heard about that. And so GitHub, LLVM has a pros and cons document about using Fabricator versus using GitHub, which is interesting. And you reckon they are probably going to move to GitHub as well? Yeah, I can understand. I'm in favor of moving to GitHub as well. I think what's also telling is, like, the person who started LLVM, Chris Ledner, for kind of at the time there was no Circle CI and so on, and they did everything in the way they did it. But his latest big project, namely Swift, doesn't use Fabricator anymore. So maybe he's learned something. I don't know. Anyway, it's a difficult discussion because there's a lot of but I'm used to this, we have used this for a long time. Also, Simon Marlowe recently made the point on the mailing list that he really likes to have access to all the old documentation, which is, not documentation, comments which are on old code reviews, which of course should be possible to keep around. But then there's another tool to consider. Yeah, so it's difficult. But it, for the moment, means we have a worse CI solution than we could have otherwise. All right, so what do you do if you want to use, or you fork GHC and you want to test your integrations? So that's one other reason for not having self-hosted service, is that when you fork GHC, you can just register on Circle CI, which means if you have a GitHub account, which you have, because otherwise you couldn't have forked GHC, you just register as Circle CI as well, and then you can just run the builds on your own Circle CI account. Now, that by default comes with a certain build contingency, which you can ask them to increase that, which is necessary, I think, for the longer running tests. But in any case, this is meaning if you're on a free plan. So that's what I guess most contributors would want to do. Unless you do this for your company, which may already have a Circle CI subscription, and then, of course, you can use as many resources as they let you. So that's nice. So it basically means, in contrast to a self-hosted solution, it's somewhat scalable. If there are more contributors who want to run more tests because they do that on their own accounts, it doesn't all bunch up on the self-hosted service by... Yeah. So on the free accounts, it just means you have less cores, you have a shorter build limit. But as I said, so Circle CI lets you, if you work on an open source project, which you're doing if you fork GHC, lets you can request an increase to the build limit. You won't get more build resources, but you can get the timeout extended. Yeah. I don't know how long it takes on a free account at the moment. I think we use a 6-way account or so for the main GHC build at the moment, which of course makes it a lot faster. Yeah, so it takes a while. It's a big test suite. Right, so unfortunately the situation is not so good with Appware because their limit is, it's a smaller company, they have shorter limits. So there's at the moment no way to run the CI build, GHC CI build for Windows on the free plan. And as I said, so the way we we are working is that Google provides us with some resources to build everything. That's definitely a limitation, but the current situation. Then, of course, what should happen is that once you submit a patch, our GHC headquarters, basically infrastructure takes over to do the test again for the merge. But that's not currently happening because with Fabricator we can't do it properly. So you can, of course, submit, so you can submit pull requests on GitHub. In fact, although the GitHub page says you shouldn't submit anything, there has been a change in policy a while ago, which is just not very well documented, and that's that for small, whatever that means, pull requests, you're free to use GitHub. And you can do that. And we can, of course, constantly slightly improve the size of our contributions via GitHub. Maybe that way we can get kind of a community-driven adoption of GitHub. How about that? If you want to contribute to the CI infrastructure, that's actually quite easy because all the configurations for the CI, they're part of the normal GitHub repository. So if you change something which is a good change, which you want to contribute back to GHC, then that's again just a normal pull request. Mm-hmm. So the question is, couldn't we have a mix where we do a pull request on GitHub, run the CI, and then transfer things over to Fabricator? Yes and no. So this is something we discussed. We could do that. The problem is then usually, especially with GHC's policy of fairly big pull requests, it usually means during code review, you will be asked to make further changes. And then what you do on GitHub, you push them into the same branch. And then that's hard to make show up on Fabricator. And something we've discussed doing, writing some custom tooling to kind of integrate that, but it seems difficult. If somebody knows how to do that properly, that would be awesome. Mm-hmm. To GitHub, yeah. So all the Circle CI builds which run on the merge changes, they all are triggered from GitHub automatically. That's currently not activated, I believe, but it would be very easy to set up. Yeah. Yeah. Okay. So, well, it's hackathon, right? So pick your projects. There are some ideas with track numbers. It's all things we've talked about with stacked head, making the ticket screen, CI for cross-compilation. That's something which we haven't done yet, but it would be very worthwhile to do cross-compilation for something like ARM and do proper CI on that. Working on release artifacts, better documentation on GitHub about the current situation, all be great things to do. Or maybe you have your own idea, if there are any more, I mean, we had a lot of discussion already, but if you have any more ideas, well, let's talk about them. Oh, sorry, you didn't manage to get, yeah, sure. I can leave it here. I mean, we can talk about projects and so on, just whatever the plan is. Okay, thanks very much for listening in any case.